Now, if you take a look at this one right here, we again had two pieces. We have this fantastic guy, which, what kind of shape is he? He's a parabola. What about the other guy? So what you're going to do is you're going to graph these guys, but you have to put in cuts here. This guy is going to have a cut when x is -1. So let me go ahead and do that for us. So when x is -1, I'm going to go ahead and put in my little cut line, which means I'm going to stay on one of the sides of this guy. Do I keep the stuff on the left or the stuff on the right for this one? What do you think? It says x's are less than -1. So what side of that do we keep? The left side. I want you to graph this guy. What do you know about him? And I'm going to identify this guy as number 1. What do you know about number 1? So we're going to be going left 3, up 5, but what's the shape? It's a parabola. What else have we done with this guy? So this guy is going to be flipped upside down. But first I put my vertex, which is -3 and up 5, so right here. Now notice, when I graph this guy, I cannot go past this line. So I'm going to do this in pencil first, that way we can see what we keep and what we don't keep. This is upside down parabola. I haven't been stretched or compressed. What's 1 squared? 1 squared is 1, 2 squared is, so down 4, 3 squared is down 9. So it would be right here, but can I cross all the way over here? No, that doesn't work out. But I'm going to reflect these points back over here. The 1, 4, the 9. After that will come 16, but I don't have room for that, do I? Now, here's an important question to ask you guys. This point that's right here on the cut line, is he included or not? If you say he's not, why not? It's not equal to. So that less than part means at this point, it's going to be an open circle. And this point over here is not going to, it's not going to happen. So I draw my parabolic shape, but I have to stop right here. I know that the normal parabola would keep going, but the piecewise defined function doesn't let me do that. It says, I'm sorry, you got to -1. You can stop now. But you have to graph all the way on the left side though, so keep graphing this guy. We're going to get that nice parabolic shape, and as we saw earlier today, all right, Karis, we're supposed to be aiming somewhere down here. So let's make sure that we do have our sights set correctly. Now, look here, I put an arrow, but I didn't put an arrow here. Why not? This guy goes all the way down forever, never going down into the left, but we stop right here. Okay, but look at your other piece. So if I look at the second piece, tell me everything you know about that guy. We go to the right, 5, and then what? What else do we know? It's, first of all, it's an absolute value shape, right? But it's also been stretched. Do you all agree? Now, he has a different cut line. Is his cut line at -1? Where's his cut line? At 2. So right here at 2, I'm going to go ahead and draw my cut line right here, which means I cannot go past this. Do I keep the stuff on the left or the right side of this? It says greater than, which means I'm going to keep stuff on the right side. What are the coordinates for your vertex? Right 5 down 2 means what? 5, -2. So my vertex is 5, -2 like that. How do you get the rest of your points? Right, now keep in mind, you've gone right 5 and down 2. I don't need that stuff anymore. I need my absolute value stretched. I can use this guy as a slope only because he's absolute value. So from here I'm going to do what? Up 3 over 1, up 3 over 1, and so on. Repeat that on the left side, up 3 over 1, up 3 over 1. What about this point right here? Is it open or closed? Why would it be closed? It's going to be open because I don't have what? I don't have equal to, so I would have an open point here. And then I go through my points. Remember, your absolute value doesn't curve. It has a nice corner here. And I just keep on going like this. Now, if I were to look at this, here's a good question for you based on what we've seen so far. What is the domain for this function? Well, it's not negative infinity to infinity, because look, I take a break right here in the middle. Negative infinity to negative 1, union what? 2 to infinity. And I'm using parentheses on negative 1 and 2 because I don't get to include that. And what about your range? This would be all real numbers, right, Zach? Because this guy goes all the way down. He maxes out right here. But look at this other guy. He continues and goes all the way up. So it would be from negative infinity to infinity. And if I were to ask you just a couple of quick questions here, and said evaluate, what is f of negative 3? And you know what? You can use the picture too. You don't have to use this stuff if you don't want to, as long as your graph is correct. So this means x is what? Negative 3. Find the corresponding what? Y value. So when x is negative 3, what's y in my graph? Right here, I have negative 3, 5. So my answer here is just 5. If you don't believe me, negative 3 gets plugged into the top guy right here. And when you do the math, guess what you're going to get? 5. What is f of 7? You look at your picture, you have this point right here, which is at the order pair 7, 4. So your answer is just 4. What is f of 0? Look on your graph. What is f of 0? So you're saying when x is 0, y is 0. So the origin is part of what I graphed here. Say it louder so everybody on YouTube can hear you.
Undefined.
Undefined. Now, why do you say that's undefined? Right, now look at this. This is your domain, right? Is 0 included in this domain? Since 0 is not included in this domain, your function is not defined. Your function, that means your function is not able to handle x values outside of your domain. So anything that falls in between negative 1 and 2 inclusive, our function doesn't have anything for that. So you would just have to say undefined. Any questions about that?